Greetings, this is Mr. Garwood with yet another video about related rates in our continuing video series on Calculus 2nd edition by Briggs, Cochran, and Gillette. We are going to do my absolute favorite related rates problem of the universe today. I'm going to hold this here, pause your video if you want to write it down. This is question 23 in the text on the problems from it. This is the infamous ladder problem. And my calculus teacher in high school, Ms. Jones, whom I love and adore, I still talk to her. In fact, she has given me some of her resources on this. She loved to make us do ladder problems. I don't know why she loved ladder problems, but the woman did. Now, like all related rates problems, I have to draw a picture first. So I've got a ladder. It is leaning against a building. The ladder is 13 feet long. That will never change. We're going to assume that we are Clark Griswold, and no matter what happens, as I'm on the ladder is 13 feet tall. It tells me that Jack is pulling the ladder at 5 feet per, or 0.5 feet per second. So he is pulling the ladder away from the wall because he likes seeing people fall. And then he asks, the question is how fast is the ladder falling when the foot of the ladder is 5 feet? Now, this is like the Christmas vacation calculus problem. You are welcome. So, how on God's green earth am I going to find an equation for how this works? And the answer is, it's your favorite equation of all time. Here comes the Pythagorean theorem. Now, first of all, I caught this because, well, I'm a math loser and I know my Pythagorean triples, but I know that 13 squared plus 5 equals 5 squared plus some other number squared. Let's call that y, because I'm about to call that side y. 13 squared is 169. 5 squared is 25, and that plus y squared should be 169. Subtract 25 on both sides, I get 144 equals y squared, which means that y is 12. So 5, 12, just like a 3, 4, 5 triangle is right, a 5, 12, 13 triangle is right. Now, what else do I know? So I'm going to call this side x, I'm going to call this side y, because I'm really unimaginative. Horizontal x, vertical y. Now, I know, I don't care what x and y are, they are 13 squared if I add their squares. There's my equation. I've talked about in related rates, the magic thing is I have to have an equation to start with, because once I have that, I can integrate. Now, what do I know? dx dt is 0.5 feet per second. And these are dastardly because you have to think about, is it increasing or decreasing? Because the sign matters. Now, I am pulling the ladder away from the wall. The ladder is going this way, which means x is getting bigger. This is positive. If I was like pushing the ladder up, if he was pushing that ladder so that it went higher, it was doing this instead of doing this, I would make that negative. But x is getting bigger, which means dx dt is positive, and I want to know dy dt when x equals 5. Now, goodness gracious, what do I got to do? Well, it goes right back. Here we go. The derivative with respect to time of x squared plus y squared equals the derivative with respect to time of 169. Now, this gives me 2x times dx dt plus 2y dy dt equals 0. Well, wait. Do I have everything I need? Let me think. X is 5, so I've got 2 times 5 feet times 0.5 feet per second plus, oh, I should have made myself way more room. Let's just start over. 2 times 5 feet times 0.5 feet per second plus 2 times 12 feet times dy dt, which I don't know, equals 0. Okay, well, this is 5 feet squared per second plus 24 feet equals 0. I'm going to and this is 24 feet dy dt. Okay, I'm going to subtract 5 feet squared from both sides, so I've got 24 feet dy dt equals negative 5 feet squared per second. Notice that became negative. Divide both sides by 24 feet. I've got dy dt equals negative 5 over 24 feet per second. Now notice that number one, my units came out exactly the way I'd want them to. I'm going to be falling in feet per second. And I have a negative because the height is, if I'm pulling the ladder this way, the height has to be coming down. So not only do the units take care of themselves here, so too does the direction and the sign. It's fantastic. So how fast is the ladder falling? It's falling at negative 5 over 24, which is right around 0.2 feet per second. And I hope that you have found this video useful, and good luck as our course continues.